So in the last video, we derived the integration by parts formula, and in this video, we're actually going to use it and see how it works. So let's remind ourselves what that is. If you have u, the integral of u dv, we know that that can be found by doing uv minus v du. And all that's left to us is to choose a u and a dv. We get v by integrating dv. So we take our function our target function, and we need to try to find a suitable u and a suitable dv. But I would like to note that you don't just go diving in and using integration by parts every time you see just two functions of x being multiplied, because as I showed in the last video on the derivation of integration by parts, sometimes this can be solved by u substitution. But we did also see that this particular case can't be solved by u substitution. So we're going to go ahead and use integration by parts, and let's see how to select a proper u and a proper dv. So if I let cosine of 5x be u, then let's just try that real quick. Write a little bit clearer than that. U equals cosine of 5x. Well, if I differentiate this with respect to x, and I'm going to get du dx is equal to negative sine of 5x, right? Multiplied, this whole thing multiplied by 5. And that's not helpful. There's no negative sine of 5x in this equation or in this integral rather to substitute for. And this is just making things more complex. This isn't bringing anything into a simpler domain here. So that's probably not a good way to go about this. Instead, we only have one other function, right, to choose. We have x. Now, you might be yelling at your screen right now saying, I just said in the last video, you don't do a substitution u equals x. But remember, that's for a u substitution application. Here, we're using integration by parts. We're not doing a u substitution. In integration by parts, it could totally make sense to do u equals x. And so if we do that, if we integrate both sides, differentiate both sides, keep saying that, we get that du over dx equals 1. If you move dx to the other side, you just see that du is equal to dx. And if we do that, we have to see that the only thing we can do for this cosine of 5x dx is to let that equal our dv. So if we say dv is equal to cosine of 5x dx, well, we need to find v, right? How do we find v? Well, we integrate both sides. The integral of dv is v, and I'll show you, right? The integral of dv is also the same thing as saying the integral of 1 times dv, right? And we know that the integral of just 1 with respect to some constant with respect to some variable is just that constant times that variable. So that would be just v here. And if we take the integral of one side, we must take the integral of the other side. If we have cosine of 5x dx, we need to take the integral of that. So we see that v is going to equal the integral of cosine 5x. So how do we take the integral of cosine of 5x? Well, we have to think sort of in reverse. If we're taking the integral, we're basically asking what function did we take the derivative of to get cosine of 5x? Well, we know that if you differentiate, and I hope I said derivative and not integral back there. If we differentiate the function sine of 5x, we'll get cosine of 5x times 5, right? So we need to account for that chain rule there with that times 5. So let me go back here and say that the integral of cosine of 5x would be sine of 5x over 5. And if that's confusing, let's think about how we would get dv, right? Which is what we had up here, dv is supposed to be equal to cosine of 5x. Well, if we differentiate both sides here, we would get dv over dx, and this would be cosine of 5x times 5. But we have a 5 here, right? So the 5s would cancel. That's why you divide by 5. And then if you moved, the dx over, you would get cosine of 5x dx. So the integral we see of that cosine of 5x dx is sine of 5x over 5. Now you might also be wondering why not plus c at the end here, right? Because this is an indefinite integral. The reason we don't put the plus c yet is because we are going to basically have all of our constants adding up at the very end of the problem, which will just be, again, one big constant. If you add a bunch of constants, they still equal a constant. So let's not even worry about that now. Let's add the constant at the very end. So now we know what u is, we know what du is, we know what v is and dv. So let's actually apply the integration by parts formula to solve this problem. The integral of cosine of the integral of x times cosine of 5x dx. And we see that that's equal to u via the per the integration by parts formula. That's uv, which is u is just x, v is sine of 5x over 5, minus the integral of v du. V is sine of 5x over 5. Over 5, that's like the same thing as saying multiplied by 1/5, and 1/5 is a constant. Let's bring that outside of our integral. And we have minus 1/5 times the integral of sine of 5x dx. Okay. X times sine of 5x over 5, well, that's not going to change. We're not integrating that any further. So I'll just go ahead and write this real quick as just 1/5 times x sine of 5x minus 1/5 times this integral here, which we know how to solve. This is similar to what we did earlier when we had dv being cosine of 5x dx. Here we have sine of 5x dx. We just have to use the same logic, but now we need to think about what function, when you differentiate it, gives you sine of 5x. Well, I know that the derivative of cosine of 5x would give you negative sine, but here we have positive sine. So why don't we say that that's negative cosine of 5x, right? We have this 5 here we need to divide by because of the chain rule, right? If we differentiate negative cosine of 5x, we're going to get positive sine, right? Because you're going to get negative times negative sine. So you get positive sine of 5x times 5, right? But we don't have a 5 here. I know it's out here, but that's separate. That's we've already pulled that out of the integral. So it'd be times 5. You need to account for that here, so we have to divide by 5. Okay, and then now we can add in our constant. So now I just want to make things a little simpler here, and by noting any sort of common factors in our terms. Here we have a 1/5, here we have a 1/5. So why don't we factor out a 1/5? And we see that the whole thing is multiplied by x times sine of 5x, and it would be minus negative cosine of 5x over 5, but minus a negative is a positive. So that's plus cosine of 5x over 5. Don't let these, when you're doing these trig functions that have a coefficient on your x, don't let those confuse you. Once you factor one of them out of your integral, pulling out of your integral, don't forget to add the other one in, right? It's there, it counts. So you need to make sure that you don't forget this division by 5 here, and plus our constant. And that is the answer to our integral that we couldn't have solved by any other means that we have learned previously, by just taking simple antiderivatives or by doing use substitutions. And I'll do another video with some further integration by parts problems just to really demonstrate how to use it.